Thank you very much, Agnieszka. Good afternoon or good morning to you all. And thank you for being with us today to discuss the IEA detailed energy consumption data. So I'm Thomas Agosi, working on the team responsible for energy end uses and demand data and efficiency indicators built with the relevant activity data. We'll now explore what one can get from understanding the demand side of the energy system, the analysis that can be done with detailed data, and touch upon how they can be collected. So here's a quick agenda, a quick note. You'll see that some of the data presented here might not be the most up-to-date. It's often because COVID had such an impact on consumption patterns. So to give you the general idea, best was to use pre-COVID data. Please feel free to ask any question either today or later via email. So let's start with why we need to look at the demand side of the energy system beyond the sectoral level and the analysis we can do with them. So first, as for a budget, the energy system is a complex set of intertwined flows. Here we have the incoming energy flows on the left, like revenues in a budget, and outgoing flows on the right, like expenditure. To manage a budget, you need to study both the input and the output. So here we'll need to look at the details of how we consume energy, the output side. At the IEA's Energy Data Center, we like to split energy consumption into four main sectors. Industry, that contains manufacturing, as well as other industries like mining, services, residential, and transport. In the IEA countries, transport is the most consuming sector. It counts for about a third of the consumption. Then comes industry with about a fourth, then buildings with residential buildings, about 20%, and services, 15%. So as you can see, no sector can be left behind as they all weigh a significant part of the system. Note that these share vary greatly, in particular depending on industrial development versus services maturity, or on transport depending on country size, and etc. So you may wonder though, what are the underlying details of this consumption? Which parts of the economy is the most sensitive to price, for instance, or to energy supply disruptions? Which subsectors are efficient and which ones need help to improve? Which sectors we need to focus on regarding emissions or pollutions? For all of this, we need to go further down the rabbit hole into the details. One of the most important analyses that we do is about energy security. With enough data, we can see which end uses are the most reliant on some fuels and which impact any disruption may have on them. It helps derive policy about supply, of course, but also about sobriety and efficiency, about technological deployment, or even just about infrastructures and maintenance. It may have deep consequences depending on past policy decisions. An important point is that climate roadmaps and other environmental targets can be achieved only with control over our energy spending. Here is a graph from the latest update of the IEA Net Zero 2050 roadmap, a major analysis from the IEA. We can see how much each mitigation measures contribute to the net zero target. If you look carefully, you'll see they almost all depend on the demand side of the system. We have lifestyles and their impact, that is demand. We also have efficiency, it's demand side again. Then a number of fuel switches, that is how the tools we use and which consume one fuel will be adapted to consume something else. And then CCUS. So the fine understanding of energy consumption is a key aspect to manage our energy system. These lead many countries to build and track energy consumption and efficiency strategies. Some focus on renewables, others on efficiency, others on data management systems, and so on. They are all based on some kind of data collection as the foundation of the policy analysis. And as energy permeates all aspects of our daily lives, a key analysis is energy expenditure. That is how much money is spent in our energy consumption and which share it represents in our financial budget. In Western Europe, 2022 was an important year as several energy products prices spiked, implying strong policy responses. Tracking the impact of such policies require a good data set of energy consumption detailed by end uses and by fuels, along with prices data. And finally, a very interesting analysis that can be performed with enough data is decomposition analysis, in which the energy consumption trend is split into three main factors: activity, structure, and efficiency. At the last COP in Dubai last year, the parties committed to a goal of doubling energy efficiency. And this is the analysis that allows us to track that goal by offsetting the growth of the production and its structure from the intensity of the processes. Okay, so let's now look at the IEA's data collection on energy consumption and efficiency indicators. The IEA decided in the 2009 Governing Board meeting at ministerial level to collect detailed end-use consumption data annually. The action plan approved at that meeting, including the objective to promote energy efficiency. So end-use data and statistics need to be collected annually to develop and track consumption patterns and energy efficiency indicators. The IEA, in concert with international experts, developed a questionnaire template based on a robust, harmonized methodology. This includes also an internal consistency and comparison check that we perform hand in hand with our counterparts in the institutions that are providing us with the data to ensure data quality and assist when other issues arise. Recall that an efficiency indicator is defined as the ratio of energy consumption by some related activity data. The basis of the IEA's methodology can be summed up with this pyramid graph. The top of the pyramid shows very aggregated indicators, such as the energy intensity of the whole economy. It's an interesting proxy to compare the trend of various countries, for instance, but it doesn't give many insights for policy decision. The further down one goes, the more data one needs, with subsectoral and end-use data, along with the related activity data, for instance, the tons of good produced or the number of square meters of housing heated. One can identify the focus point for improvements, whether through investments, technological upgrades, social measure, etc. The IEA Energy End Uses and Efficiency Indicators database gathers energy consumption data split by end uses, such as basic metal for industry or space heating for buildings. Also by fuels, such as gas, oil, electricity, as well as different oil products in the transport sector, like gasoline and diesel. We also collect related sectoral activity to build indicators, such as value added for commercial sectors, number of dwellings in residential or vehicle kilometers in the transport sector. And we provide the indicators themselves. And finally, with enough data, when there are enough data available with the same methodology, we give the results of our energy and carbon decomposition analysis, splitting transport by segment and merging the two commercial sectors. This very detailed database covers 31 member countries, 5 association countries, 3 accession countries, and 22 countries beyond the A family. That covers about 2 billion people. As we wish to include as many countries as possible, we're always working bilaterally with multiple institutions to make this database as representative and complete as possible. We welcome any question on international methodologies or any experience on data collections from any country. We'll come back to that later. Recall that pretty much no country has data about everything, but very often data is first collected on the most important sector and then expands. So from all these data collected, the IEA Energy Data Center compiles a large database available on our webpage. To make it user-friendly, the main publication in Excel provides all this data as well as a set of interactive graphs and visualization tools to assist the analysis. The full database, formerly available in IVT format, will soon be available on a new SDMX interface. We also provide the demo availability file, a free sample, which is also in Excel. Another way to browse our data is the Data Explorer with a web interface to produce the graphs. And finally, we maintain a documentation with methodology and detailed country notes, as well as 2 manuals on statistics and policy making. I will now dig into the sectoral methodology, providing examples of data and indicators. So on the industry, the energy consumption can be split by subsectors. So this is subsectors which can be very intensive, like iron and steel, or less intensive, like maybe textiles. And we add to that the activity data that can be either value added, as we mentioned before, but also physical production, especially in homogeneous sectors. Here are, for a selection of countries, the 6 most consuming subsectors. Each of them use different fuels with general trends and country specificities. Chemicals, for instance, often depends on gas, while wood and paper may use significant amount of biofuels and waste. Basic metals may rely mainly on fossil fuels or on electricity, depending on technology choices. Tracking these splits allows to anticipate the impacts of policies and regulation. It's also essential for the energy security analysis, especially for subsectors depending mostly on one energy product. We have 2 types of indicators, as I said, the one per value added. It requires harmonized value added data using, for instance, deflators and purchasing power parity, but they are good to compare sectors, countries, and to follow trends. The indicator for physical output requires careful methodology, especially on trade and intermediate products, but they are helpful to avoid currency issues and excellent at plant level or to track technological deployment. On the residential sector, we have an approach which is based on the building point of view of the residential sector. So we split by end uses such as space heating or water heating. And the activity data, we have data such as the population, also occupied dwellings, floor area, and for the case of energy consumption split by different appliances type, we also collect the appliances stock and diffusion. For residential consumption by end uses and fuel, one can see the influence of the climate, for instance, little space heating in Morocco, as well the share of fuel, and fuel split for cooking. We can know that it's very dependent on lifestyle, such as habit of eating out, cooking methods, and types of stoves. The fuel split of most consuming end uses are central to understand the reliance on imports, the impact of price variations, the design of emission and efficiency programs, as well as health-related issues such as indoor pollution. Note that we can correct the energy consumption for space heating and space cooling to better track the trends using indicators of the weather of that year. This is called temperature correction or weather correction. It allows to remove the impact of a particularly cold or hot year on the energy consumption. Please refer to our documentation for more details, and if we had time, we can get into the details of this methodology as well. On the services sector, we have two split, which is very interesting, the split by from the building point of view and the split from the economic point of view. On the building point of view, we have the split with end uses such as space heating and space cooling and water heating like we had for the residential buildings. And for the activity side of it, we have the split by subsectors such as retail or education. And then we use related data to build indicators such as value added, exactly as for the industry sector, but also services floor area and the number of employees. We usually categorize services into 11 subsectors. Here, about half of the energy consumption is covered by only 3 subsectors: administrative services such as finance, insurance, real estate, or science, health and social work, and retail. But the weight of each subsector in energy terms might not relate to its output expressed in value added. For instance, accommodation and food services provide little wealth while it consumes 10% approximately of the service energy in this country. The energy efficiency indicator here in megajoules per USD shows that the finances and other administrative activities have a significantly lower intensity than accommodation and food services, for instance. Alternatively, we can build indicators per floor area. It shows the lower intensity of accommodation and food services with respect to wholesale and retail, for instance. So a careful analysis of the data is needed to identify which indicators makes the most sense to assist correctly the policy making. And finally, on transport, the energy consumption data can be split by segment, which is freight versus passenger, as well as by mode. That is the road transport that can be split further by vehicle type, for instance, between passenger car and buses and motorcycles. The road freight transport and the rail transport can also be split by vehicle type depending on the importance of these modes and segments in the respective country. And finally, the needed activity encompasses many different kinds of data. We have vehicle stocks, the distance traveled by vehicle, which we merge with the stocks into vehicle kilometers, and the vehicle loads, whether in freight or passenger transport, which is then computed into PKM and TKM, as we'll see now. So passenger kilometer and ton kilometer, as I said, we take the vehicle stock and the distance traveled, we multiply each other, and it represents the sum of all the journeys traveled by my stock of vehicles. Then if I multiply this by the occupancy, say the load factor, so that is the average number of ton in the stock of vehicles, I get the ton kilometers. It represents the journeys of each ton and the sum of these journeys into an activity measure of my freight segment. Splitting is already simple into these 4 main modes. We have here data for the IEA countries. road takes about 80% of the consumption, but we also have rail and air and water transport. Here, air transport is quite important. Then by fuel, and we see that oil products account for the overwhelming majority of the consumption, about 98%, and even just two, namely gasoline and diesel, represent a huge part. So if we want to know more and go a bit beyond this very simple analysis, what are the splits that we want to know, how further we want to get data? Looking, for example, at activity data, we see that cars account for a very large share of passenger activity in the USA, about 80%, larger than in Korea. This might explain consumption patterns or show differences in efficiency, in habits, or in the usage of car. The same data would be needed for the freight segment. And as I said in the introduction, you can perform a decomposition analysis once the picture is somehow complete. In the transport sector, that means data for each segment across all modes and ideally all vehicle types, being very careful with methodological alignment between these data series. The decomposition analysis takes integral activities. Here, that's the amount of goods or the number of passengers and the distance traveled. The structure that encompasses, for instance, the modal shift, for instance, between cars to buses or to trains. And the efficiency that takes into account things like the load factor, the engine efficiency, the driving behavior, etc. In the example here, in the passenger segment, on the right, efficiency gains have compensated for increased activity overall, leading to a stable consumption somehow. On the freight side on the left, on the contrary, efficiency deteriorated, probably through lower load factors, for instance, to accommodate with more stringent deadlines, which implies that your overall efficiency is not as great. We also see that structural effects seem to have been influenced by the 2008 crisis with a big dip. So let's have a quick turn now on the IEA tools regarding how to collect the data. As we've seen, and you've seen in also previous presentation, that this is no simple task. First of all, we'd like to recall that gathering and estimating energy consumption by end users at national level and developing efficiency indicators can be very challenging. This is why it requires the right resources at national level, but also the support of international and regional entities. In general, data collection, as you've seen in previous presentations, can be categorized in four main methods. I'll skip this slide as I think you've seen it several times. I'll give you, though, some, I think, tailored examples for this type of data collection. So for commercial activities, interesting sources can be found through economic authorities, such as the Chamber of Commerce, regulation authorities, or tax reports. It can be complemented with energy companies' data or sales report. These sectors often already collect a significant amount of data for themselves, which is great. The main trick is to gather them and ensure the methodological consistency. Buildings are often requiring the most varied data sources, whether residential building or services from an end-use point of view. With basic activity data such as population, employment, dwellings, or floor area, usually covered by administrative sources, most energy consumption data relies on a combination of surveys and measuring in best cases. Modeling also allows to avoid repeating costly surveys too often. And finally, in the transport sector, many data exist from oil consumption to car sales or registrations, but these need some manipulations, if not modeling, to obtain data split by modes and vehicle types. So surveys are also needed to provide the basis for model calibration and to complement where data is lacking. These were the main ideas, but of course, every country, every sector, and every situation might appear unique. The truth is, other countries' experience are incredibly valuable resources when one needs to collect new data. That is why the IEA gathered online numerous data collection practices, along with some documentation, survey examples, and reports from many countries around the world. It covers a huge diversity of situations, from Indonesia to Bosnia-Herzegovina, from industry to residential, from service to modeling. You will for sure find some insight by browsing this tool, and we also welcome any country that has some interesting experience to share with us and to share with other countries. We can also put you in contact with the institution in charge of this data collection if need be, if of interest to you. To complement and strengthen this framework, the IEA recently developed 2 guides to build national roadmaps, one on energy statistics in general to strengthen national capacity for tracking energy transition. It is called Designing an Energy Statistics Roadmap. We'll give you the link in the chat. The second one shown here focuses on the demand side. It aims first at helping countries locating their departure point and to identify the targets according to national interest and to priorities. Then building on countries' experiences again, it assists professionals and decision makers in their data collections by providing a generic method while acknowledging the contextual differences. International collaborations are again crucial to speed up the learning process and to keep up with the pace of technological, economic, and geopolitical changes. The IEA commitment to build capacity in any country looking for assistance also shows in this new tool that we are just finalizing currently. It's a toolkit to estimate disaggregated data to be published very soon. The idea is to provide a simple, adaptable tool to model and use data from more commonly available data. One typical example is splitting residential energy into the different end uses, using, for instance, other administrative sources, or for instance, also using vehicle registries to devise vehicle stocks depending on the lifetime of the vehicle. So feel free to reach out for any of these resources or to discuss other assistance on methodology. With this in mind, I thank you very much for your attention, and please feel free to comment or question any part of the presentation. Thank you very much.